Industry today is shattering records for productivity. In all kinds of industry, as for example in glass making, immense quantities of raw materials are transformed into goods for the market. Here, raw materials are fed into a glass furnace. Processing these materials requires specially designed equipment and mass production techniques. Partly these develop out of ingenuity and chance, and partly out of experimentation. The results are products for the home, like the glassware being made here, and products for other aspects of modern living. Since a high rate of industrial productivity benefits everyone by providing better products at less cost, it is important for laymen as well as industrialists to understand what makes such production possible. Basic to this understanding is a knowledge of industrial organization. Each company is directed by a team of experts, the leaders of different specialized departments. Each department has a particular contribution to make to the work of the company it represents. For example, the production department relies upon men and machines to turn out finished products for the sales department to sell. In addition to production and sales, a purchasing department buys necessary raw materials, parts, and machines, and a financial department accounts for and finances all purchases. It also takes an engineering department to design and test equipment intended to increase the daily output of each worker and decrease drudgery. But newest of all the departments to gain a position of eminence in industry is research. Research is responsible for getting reliable answers to problems that affect the technology underlying production. Setting up experiments and intelligently interpreting the data revealed by these experiments is an important part of this research, which leads to improvements in old products, development of new products, and reduced costs for consumers. Industrial research concentrates on discovering facts that can be applied. Products of research are commonplace. They could be pictured in many different settings. But because of the universal use of glass products, the glass industry is selected as background for this story of progress. Glass in its many different forms provides one of the most versatile substances ever devised by man. In the home, it takes such different forms as windows, draperies, decorations, and tableware. One of the common forms is molded glass. Molding processes are used to make bottles and hundreds of varieties of glass containers to package goods for the market. Flat glass, window panes, and plate glass are forms known to everyone. Glass is made into corrugated panels, covers to protect delicate instruments, blocks for construction, acoustic tiles to deaden sound, picture tubes for television sets. Glass can be made into panels containing electrical resistance wires that radiate heat. Whatever the kind of glass, each is adapted to some special use. Some kinds are chiefly useful in the home. Others serve industry or the professions. The properties of each kind depend upon its ingredients. Glass through the ages and until 1880 usually consisted of sand, soda ash, and limestone. Mixtures that go into modern glass contain additional substances. Each is added to produce some special quality not attained by glass craftsmen of the past. Besides changes in mixtures, improvements have been made in the machines for making glass. Ingenuity and luck have helped develop some of the modern techniques and machines, but today it takes more than ingenuity and luck to satisfy man's increasing desires. For example, here's a tumbler. It looks perfect, but let's test it. One successful test that has been devised employs polarized light. Look for strains in the glass. They show up as dark areas. Undesirable strains could lead to early breakage. But when the tumblers are annealed by slow cooling, these strains disappear. This superior product is the result of experimental work. All systematic investigations of glass are relatively recent. Otto Schott, a German chemist, is often considered the first man ever to initiate a systematic program of research in glass. Schott's experiments were planned to improve the mixtures used to make lenses. About 1880, he began his work. He added different oxides to the customary formulas of sand, soda ash, potash, and lime. His work led to improved kinds of glass. Some of his glasses, together with others developed by his successors, make possible the high degree of perfection in modern optical equipment used to provide sharp visual images. During Schott's long life and through the intervening years, research has repeatedly demonstrated its importance. All of the fundamentally new uses for glass, as well as many of the improvements in the old, have resulted from research. Today, specialists in research continue to study the effects of new materials and procedures. Here is one such specialist. Like most of the younger technologists, he has a degree in science. His knowledge of glass developed in college. Like other students, he included field trips in his training. A special interest led him to make most of his trips to glass factories, such as a flat glass plant. This is where window glass is made. Raw materials are received by the carload. The sand, soda ash, lime, and other raw materials are measured into batches to be melted. Huge containers transport the mixtures to the furnaces. Periodically, a batch of raw materials is added to the other tons already being melted. A large furnace like this may hold several hundred tons at one time. Heat released by burning gas produces a temperature of about 2,700 degrees Fahrenheit. The heat transforms the mixture from its solid form into a molten, sticky mass. The molten glass moves from the furnace as a continuous ribbon. Knurled rolls maintain the proper thickness of this ribbon-like sheet. After passing through a cooling tunnel, the sheet is cut into sections. These sections, to be used in windows, are clearer and better than ever before. It's difficult to imagine how life would be without this product. Almost everyone has need for window glass. Plate glass, another important kind of flat glass, is made from special mixtures of raw materials. The materials are melted in a massive crucible. Once the melting temperature is reached, the batch is ready for pouring. The molten glass passes through rollers and forms a plate. Unfinished plates are sometimes called blanks. As soon as they have cooled, the blanks are ready for finishing. To simplify lifting and handling the large, heavy plates, glassmakers use equipment fitted with specially designed suction cups. Finishing means grinding and polishing. These processes remove any roughness on the surfaces of the rolled plate. After the final polishing, the surfaces are so flat that each is almost a perfect plane. These plates are thicker than ordinary window glass and permit vision with very little distortion. Production methods for plate glass have been improved so greatly in this century that it is now available at relatively low cost. Much plate glass is used to make automobile windows. Containers such as bottles are another type of product in use for centuries. Of course, the glass makers of 100 years ago never saw containers like these. Making glass containers, such as bottles, is one of the most economically important branches of the entire industry. Bottles are made by blowing, as they were in the days of glass blowers. But the quality of glass bottles has been greatly improved, and the methods of production highly developed. Today, containers are not only better than ever before, but they are produced at rates that would astound glassmakers of even half a century ago. Virtually every home or market in the world has use for some examples of the container industry's products. In some modern factories, glass blowers still practice their ancient art. No amount of systematic research or ingenuity has yet devised machines and procedures for making certain types of glassware. Glass blowers follow techniques handed down by generations of their predecessors. Precision and craftsmanship result from long years of experience. Here, a volumetric flask is being blown by using a blow mold. Glass blowers make equipment like this flask for the laboratories of science. But like any hand operation, their output is limited. Wherever possible, machine production replaces this colorful art. Much of the laboratory wear of today is made by modern high-speed mechanical means. Even tools like these are changed as experiments reveal ways of doing the work more efficiently. Marking products like graduated cylinders requires precision machinery. The manufacturers of laboratory ware continually search for improvements, such as glassware with greater resistance to shock, new mixtures of raw materials, improved manufacturing procedures, and refinements in testing apparatus contribute to more perfect products. Most glass products have benefited from research, but some are direct results of research, such as glass blocks. Crude blocks of glass were made as far back as the days of early Rome, but such early counterparts could not compare with the quality of glass blocks today. Mass production of modern blocks is the outcome of a systematic research program begun in the early 1930s. The program was planned to perfect mixtures and develop procedures for high-speed, efficient production of blocks with unique properties. Glass blocks have opened up new uses for glass and helped make glass competitive with some of the other common construction materials. This competition favors the consumer because it offers him a greater variety of materials to select from and leads to lowered prices. It's an example of more and better products for less money, an important contribution to a high standard of living. Glass fibers, like glass blocks, have been known for centuries, but were merely curiosities until recently. To make fibers, the melted glass is formed into marbles. After inspection, the marbles are conveyed into an electric furnace. Each marble will make more than 100 miles of fibers. Fibers can be made from these marbles that are much finer than a human hair. Transformation into fibers for textiles depends upon molten glass flowing through fine holes in a platinum trough. Textiles like this drapery can be manufactured from fibers of glass. Such textiles resist many of the hazards that could destroy ordinary fabrics. The raw materials of glass can be made into other kinds of fiber products without going through a marble stage. This is glass wool. Fibers of glass wool have many valuable properties. These fibers will neither shrink nor stretch, and they will not burn, rot, or rust. The fibers can be sandwiched between layers of heavy paper to form blankets like these. Each blanket provides insulation that will block or reduce the transfer of heat. It can provide insulation for a building to help keep the interior cooler in summer and warmer in winter. To insulate buildings, the paper-covered blankets are tacked between wall or roof supports. Compressed more firmly and treated with a special binding material, glass fibers are made into a pre-formed kind of insulating board for such uses as roof and cold storage container insulation. Other types of fiber wool bats are used as insulation in appliances designed either to exclude or retain heat. Treated in other ways, fibers of glass can be made into insulation that deadens sound from automobile or aircraft engines. Retainer mats and separators for storage batteries. Pre-formed coverings for pipes. And filters for air conditioning and forced warm air heating systems. And here is a special use. This is a bulletproof vest which contains for its armor plastic sheets reinforced with glass fibers. Vests like this have saved many fighting men from vital injury in combat. In these and other ways, research helps lead from the old to the new in glass by developing better products for modern living. The practical value of research in glass is demonstrated in many settings. For example, improved optical glass has meant improved spectacles, and improved spectacles mean greater enjoyment while reading, driving, or using our eyes in other ways. Optical glass makes possible the fine lenses of cameras. More perfect lenses for microscopes contribute to the development of virtually all the sciences. The microscope reveals objects too small to be seen by the eye alone, such as this reproductive action of a one-celled animal. Nearly all aspects of biology have profited by the use of optical glass. There is always the challenge of problems yet unsolved. For example, who will discover a cheap method of extracting aluminum from clay? An ordinary clay brick contains about 1/2 pound of aluminum, but no one knows how to extract it economically. Or who will learn to harness the power of the waves, extract more of the valuable elements in seawater, or use energy directly from the sun? Who will be first to conquer outer space? Who will be the next to convert some glass mixture into a new and unique product for the market? Progress in glass, as in industry generally, becomes increasingly dependent upon research. The results of systematic experimentation may not often be as spectacular as in this production of electric lamp bulbs, but inevitably, research leads to more products at less cost to serve the needs of more people. Industry is learning to use research effectively and is thereby helping raise our standard of living. Today, men and women are working to solve many different problems. Their success will influence our future. The achievements being made in glass and in all other industries assure for industrial research a role of increasing importance in furthering industrial progress and the welfare of our society.